Hello my students, now let us proceed with today's lesson. Our today's lesson will be based much on types of stationary waves. Remember, on the last period we discussed electrobeat as stationary waves concerned. Sometimes they're called standing waves. Now today we're going to look on types of stationary waves. There are two types of stationary waves. These are transverse stationary waves. We have transverse stationary waves, but also we have longitudinal stationary waves. These are the two types of stationary waves we have: transverse and longitudinal stationary waves. Now, what are the transverse waves? Remember, for stationary wave to be formed, we need two progressive waves which are moving in opposite directions. One if it is moving from left to right, one must be moved from right to left. But they must have the same wavelengths, the same speed, the same amplitude. Those are the conditions. Therefore, for the transverse stationary wave to be formed is when we have two identical transverse waves. Two identical transverse waves traveling in opposite direction. Here we're going to have transverse standing waves. Here we need to have two longitudinal waves traveling in opposite direction. We are going to get longitudinal stationary waves. Example of transverse stationary waves is stationary waves in vibrating strings. Stationary waves in vibrating strings. But here the example is sound waves in a closed pipe, and also have sound wave in an open pipe. I think we're going to pass through the notes given to try to look what I've explained here. Now our concern will be based on the so-called transverse stationary waves. We're going to start with transverse stationary wave in a string. I said one of the example of transverse stationary wave is this transverse stationary wave in a string. I think now let us assume we have a string which is fixed at both ends. We have the string which is fixed at both ends, the end A and the end B. Now what will happen if this string is plucked at the middle? If the string is plucked at the middle, it will start moving up and down. The movement of it up and down will result into this illustration here. Will result into this diagram here. The movement of the string up and down will result into this one here. Now, do you see what is this? This is the stationary wave, which is called transverse stationary waves. Therefore, this is called the node. This is now point maximum antinode, and this is node. Therefore, if the string is plucked at the middle, it vibrates up and down. As the result, it forms the so-called stationary wave. Now, this kind of transverse stationary waves occurs mostly in string instruments like violin, guitar, piano, etc. This type of transverse stationary waves occurs in string instrument, violin, guitar, piano, etc. Now this is not the problem. Let us look on another thing concerning about transverse stationary waves in a string. And this thing is called velocity of transverse stationary waves in a string. We want to look velocity of transverse stationary waves in a string. Velocity of stationary waves in a string. Now imagine you have a string. Imagine you have a string, which is this one. This string has length L. This is the length of this string, L, fixed on both ends, at its both ends. Now, if it is fixed, that means this string, it exerts a certain tension T, and the string is not massless, it has a certain mass. Therefore, a string has a mass M, not massless string. It has a mass M. Now, how can we calculate the velocity or the speed of the string moving up and down when it is plucked at the middle? Experiment is saying the speed of this string depend on the following. The speed of the string on a transverse stationary waves depend on the following. One, it depends on the length of the string, length, L. It depends on the length of the string, L. Length of the string, L. How? In a such a way that speed, which is velocity, is directly proportional to the square root of that L. That means if the length of the string decreases, the speed of the wave increase. If the length increases, if the length increases, speed increases too. If the length decreases, the speed decreases too. That is the meaning. Second, another factor is mass. Mass of the string. How mass relates with the speed of the string? Mass is said to relate with the speed as inversely proportional to its square root. Let us assume this is question 1, this is question 2. Therefore, the string with high mass, it has low speed. The string with low mass, it has high speed. That is the meaning. Another factor which determines the speed of the transverse stationary wave is what we call tension. Tension given by letter T capital. How tension? Tension is said to relate with speed in such a way that V is directly proportional to the square of tension. That means if the tension is high, the speed is high. If the tension is low, the speed is also low. Therefore, we have three equations here, as you can see. V direct proportional to the square root of L. V is inversely proportional to the square root of M. V is direct proportional to the square root of T. Now we can combine those three equations so that we can have a single equation in a such a way that V, now this equation will be V is direct proportional. What is direct proportional? tension and L. Tension and L are direct proportional. Therefore, they are direct proportional to tension times L, and inversely proportional to M. Therefore, M is inversely proportional. We can now write this equation as we can write this equation as this equation here. This equation can be rewritten as V is direct proportional to square root, because all these are in square root, to square root of tension L over M. We can remove proportionality sign. We have V equals to K under root of tension L over M. Therefore, this is the equation. This is the equation where K is the constant, equals to 1. K is constant, equals to 1. Now, if K is equal to 1, we can have this equation as, this equation will be V equals to under root of tension L over M. Tension L over M. Therefore, this is the equation which will help us to find out the speed of the transverse stationary wave in a string. But this is not only the equation we can have. We can also try to figure out, to deduce this equation. We have said V equals to under root of tension L over M. We can write this equation as follows. For those who know mathematics, this equation can be equals to under root of tension. This L can be over tension over M over L. This equation and this one are the same, because we have just divide L over M over L. But also we can, this one, L can go to tension and be TL over M, the same thing. This equation, this one is the same. But when we write this equation as this one, we have M over L. This will change the meaning. And now we'll have V equals to tension over M of L. This factor is called mu, mass per unit length. Therefore, the equation changes to V equals to tension over mu, where mu is equal to the ratio of mass over length. This is mass per unit length, which is from this one. Mass per unit length, its physical meaning is thickness of the string. The physical meaning of mass per unit length is the thickness. Now look here, how thickness and the tension, how thickness, which is this one, and the V relates. When the string is thicker, that means the speed. When the string is thicker, that means the speed is lowered, which is correct. But when the string is thin, very thin, that means the mass per unit length is small, the speed of that string is high. Therefore, these are the factors through which the speed of the transverse stationary wave depends. Now, in exams, you'll be asking the following question. Mention three factors upon which the speed of the string depends. Three factors are mass, length, and tension. For example, now you'll also be asking, mention two factors. The question now changes to two factors which affect the speed of the transverse wave, the transverse stationary wave. The two factors are tension and mass per unit length. If at all have been asking three factors, you'll mention mass, length, and the tension. But if it is two factors, you'll mention tension and mu. Mu means mass per unit length, Or physical meaning means what? Thickness of the string. Have a short break. We're going to proceed later.